Hi. In the last class, we have seen what is a fundamental quantity, what is unit, what are different SI units, fundamental physical quantities, derived physical quantities, and the logic behind vernier calipers and screw gauge. Today, we look into the accuracy and precision of measuring instruments. Before getting into the accuracy of measuring instrument, what is a measuring instrument? In the last lecture, we have seen what is measurement. Measurement is finding the magnitude or the quantity, the quantification of physical quantity, right? Finding the magnitude, how much it is. Now, measuring instrument, the device which is used to measure is a measuring instrument. So, what are the physical quantity it is? It may be a length, or it may be width, or pressure, or force, temperature, anything. The device that you use to measure this physical quantity is measuring instrument. So that is actually any measuring instrument is a device intended to find the physical quantity. Some measuring instruments. So we know generally what are the measuring instruments. We know ruler, which is a basic measuring instrument to measure the length. And let us see some more measuring instruments here. Ammeter. I think all of you know what is an ammeter. Ammeter is used to measure current. It is used to measure current flow in a circuit. And how the ammeter will be? So the ammeter is this one. So which measures the current in amperes. In the last class we have seen the unit of current is ampere. So this is your ammeter. Similarly, if you want to, so this shows now, what is able to see here, there is some reading in kilometers. What is this? This is actually the reading of a vehicle. So what is this measuring instrument? It is odometer, right? It is odometer. What is the purpose of odometer? Used to measure distance traveled by any road vehicle, whether it's a bike, car, truck, whatever. You might have seen this, right? So these are all speeds. I'll show you what is this. But this is your odometer. So what is this? So here I have seen odometer in the center, right? So this is your speedometer. You might have seen in all the bikes, in cars, even digital speedometers are there. So this is a dial speedometer where you measure speed in kilometers per hour in this case. So what is the purpose of the speedometer? The purpose of speedometer is to measure speed of a vehicle. So next, thermometer. It's a clinical thermometer used to measure temperature. So what is this one? Any idea what is this? This is mercury barometer. What is the purpose of mercury barometer? It measures the atmospheric pressure, right? So what is its purpose? It is a barometer which is used to measure the atmospheric pressure. So here mercury is filled in this. Okay, basically there are so many measuring devices. There is voltmeter to measure voltage, so many measuring devices, pressure gauge to measure pressure. So just to have an understanding what measuring instruments, I have shown some measuring instruments. So measuring instrument basically a device which is used to measure any physical quantity. Now the most important thing is accuracy of a measuring instrument. When I say accuracy of a measuring instrument, for example, we take a case of a ruler now, small scale, which you use it generally in your classrooms to draw, right? And also in the last class we have seen vernier calipers. So which is more accurate in these two? So vernier calipers is more accurate. That means if you want to measure any physical quantity, with what closeness you are able to find it? Closeness to the actual value. I'll tell you what is that actual value. Actual value is exactly referred as true value. So to the true value, suppose you are measuring something, how accurately you are measuring means how close to the true value your measured value is. So let us try to understand what accuracy is now. So it is actually degree of closeness of a measured value to the true value. I'll tell you what true value is. So close to the true value. If you're very close to the true value, then you are accurate. Suppose you want to guess something. A vehicle is moving. There is a wild guess from your side that vehicle is moving with velocity of 80 km/h now. If vehicle is moving at a velocity of 85 and you say probably it might have moving, it is moving at a velocity of 80 km/h, you are close to that. You are so accurate. Someone says it is 70, you are better than them, right? So you are more accurate compared to others. So accuracy means how closely your value is to the actual value. Here actual value means true value. So what is true value? Let us see what is true value. What is the true value? True value means the exact value of that particular physical quantity or magnitude of that physical quantity. For example, I have this pen now. So the length of the pen. So the length of the pen. So I have to measure anyhow to know the length of the pen. Suppose how I know exactly how much it is, because only way I can find the measurement or only way I can find the length of the pen is to measure it. So then what is the true value? How can I find true value? By definition, true value refers to, because if I measure one time, I get some value, second time I get some value, third time I get some value. And whatever the measuring instrument you are using, that how much accurate it is or whether it is designed in the right way or not. That's okay. That's a second criteria which we discuss. Now, if I want to find the length of this, only way I can do is to measure it. But the point here is, I will make infinite number of times to arrive at the true value of this length of the pen. Infinite. By definition, it says infinite number of measurements and averaging that to get the true value. But in reality, we cannot measure infinite number of times. Infinite is not possible, right? So what I do is, I make finite measurements, but I take special care. I will use accurate, whatever the devices we have in measuring instruments, I try to use the most accurate device and try to fix this value with a theoretical supposition. Theoretically, I fix the value, of course, based on measurements. Because I cannot have an average value of infinite number of measurements. So with finite number of measurements, but I'll take more measurements, maybe 20 times or 30 times, even more than that, 40 times, to arrive at a true value for this. But finally, the true value I'm assigning based on the values what I get, but not an average of that, but finally fix based on whatever the values I get. I'm getting some values. We try to understand what is true value now. Just go through that. Practically, it is not possible, right? So what finally we do, it is based on theoretical suppositions. Suppose I have a values like this, for example, 30.01 mm. I'm measuring something, 30.01, 30.02, 30.01 again, 30.02, something. I'm getting so many measurements. So what theoretically I can do is I can fix the value after so many measurements, maybe 15 or 20 measurements. I'll fix the true value as 30 mm. So why I need to fix the true value? What is the purpose of true value? True value, we need not measure the true value again and again. True value is a value, actually it is used to judge the measuring devices, how accurate the measuring device is. The purpose of a true value of a particular physical quantity. That is, for example, I have some physical quantity of 30 mm, which has, suppose, a cylinder I have. Okay, I have something like this. Now let the length of this be 30 mm. So my purpose is not, so what is the purpose of this accuracy now? So I take this specimen, this will be my specimen. I use this specimen to find accuracy of the measuring devices. I am using measuring devices now. So whatever the measuring devices I am having, I have, I try to find the accuracy of measuring devices based on this value. This already fixed. Now this true value, I need not find true value with all the measuring devices again, right? So what I do is I just try to find what is the accuracy of this measuring device. So for example, I have vernier calipers. Now I find the accuracy of vernier calipers. So once I find the accuracy of the vernier calipers, I can use it for further measurements. But this is a special measurement. True value is a special measurement, and all other values which I measure are real values. So the measured values I am comparing with true value to get the accuracy of this vernier calipers. If this is accurate, if this vernier calipers is accurate, then I can use this, or I can accept the readings that are available from this vernier calipers. I can accept the readings that are calculated through this vernier calipers. So the purpose of the true value is that. The purpose of true value is to judge the measuring instrument accurate, how accurate the measuring instruments are. To judge how accurate the measuring instruments are. That's the main purpose. I hope you understand the true value. True value is a theoretical value. Practically, we cannot arrive at a true value. So special and ordinary. Ordinary means what are the measured values you have. You have specimen, you just measure it, okay, you get reading, that is ordinary value. Special case where you take extra care, you have more iterations, number of times you measure it to get a particular value. That is actually special value. That special value is a true value. And the true value is actually used to judge the measuring instrument's accuracy. So accuracy, I told you, accuracy of a measuring instrument, accuracy of a measuring instrument, what is its purpose? To accept the measured values or not. Suppose if they are not accurate, you have a true value and you are using a measuring device and you are measuring the same physical quantity again. If it is far from the true value, as I told you in the previous case, 30 mm is true value of fixing, and you are measuring something and you are getting some 34 mm. Now what do you mean by this? Your measuring instrument is not accurate. So this measuring instrument cannot be used. So that's it. So, and also what is the other one? Accuracy is important to choose the measuring instrument based on the application. So how much accuracy is intended, that is also important now. So one thing what you have seen is whether we can accept the readings of particular measuring device or not based on the accuracy. And the purpose of other one is, what is the second criteria to find accuracy is, suppose I want more accuracy. I want more accuracy. Suppose there are two measuring instruments. This is also accurate, this is also A and B. Both are accurate. But the point here is, what is my application? Depending on that, I will choose which measuring instrument I am supposed to use. For example, let us see with an example now. I need to measure the length of or dimensions of a brick. Now it's okay, right? I can do it with a small tape. I can do it with small scale, whatever. Similarly, I want to measure the diameter of an engine block. This is your engine block. So, and I want to measure the diameter of a cylinder in engine block. So can we use both? Can we use the same measuring instrument in both the cases? Not necessary, right? This I can use with a small scale, some tape or whatever it is, measuring tape I can use. But this I cannot do with that. I should go for higher accuracy measuring instrument, because what matters is the length of the length of the brick. Suppose it actually measures 9 inch, right? So if instead of length 9 inch, even if it is 10 inch, it's okay. We are just measuring. If it's close to 9 inch, 9.5 inch, 10 inch, it's okay. We can use that brick still. The purpose of the measuring brick is the application of brick is just to construct, right? We can use it, not a problem, even if it is half inch more. Maybe 10 inch we cannot accept, 9.5, yes. So instead of 10 inch, if it is 9.5 inch, it should be 9 inch. This is actual value, but even if it measures 9.5, it's okay, we can use it. So the measuring instrument need not be very accurate for this, but here the measuring instrument is very accurate, should be accurate. So suppose, here I am measuring, it's okay, I can use any measuring instrument. I don't need an accurate, the measuring instrument with high accuracy. I don't need this in this case. But if the same here, if you want to find diameter of a cylinder, I need higher accuracy measuring instrument. So that's the purpose of accuracy. So accuracy is intended for two purposes. One is whether measuring instrument is accurate or not. And second one, even though measuring instrument is accurate, how accurate it is to use in a particular application. So let us try to understand what is accuracy now. Suppose whether the accuracy of particular measuring instrument is acceptable or not. Suppose I have a thermometer. Suppose the body temperature is 103 degrees Fahrenheit. If the temperature reading is 100 Fahrenheit. So if this particular thermometer, it reads measured value as 100 Fahrenheit, but actual temperature is 103 degrees Fahrenheit. Now, this thermometer is not acceptable, right? You're getting my point? Because you're having a fever of 103 degrees Fahrenheit, and your thermometer is showing 100 degrees Fahrenheit, which I got this value from some other thermometers, for example, and this particular thermometer you are getting 100 Fahrenheit. So that means this thermometer is not having high accuracy. So the main purpose of a clinical thermometer is to measure the temperature of a human body. Now if temperature, it is having a variation of 3 degrees Fahrenheit, it looks 3%, fine, but that's very high, means the error is high in this case. So it depends upon the application now. 100 and 103 are very close values, but if you are having a temperature of 103 degrees Fahrenheit and your reading is 100 degrees Fahrenheit, so obviously it will affect your temperature. I mean, it will affect your diagnosis itself. So this thermometer is not acceptable. So this is the purpose of accuracy now. So here we need more accuracy. Here we need more accuracy. So the accuracy, the purpose of the application actually defines how much accuracy should be there. If the thermometer reading is 102.5, it's okay. You are having a temperature of 103 degrees centigrade and your thermometer is showing 102.5 degrees Fahrenheit. It's fine, absolutely fine. You can use this thermometer, not a problem. But this thermometer we cannot use. How is accuracy calculated, or how much is the accuracy? So suppose I have a thermometer like this. This is laboratory thermometer. We have readings of, you can see here, 100 degrees. Okay. So you can measure till 100 degrees centigrade. The true value of temperature of liquid in lab is 56.5 degrees centigrade. That's a true value. Measured value is between 56 and 57. So this is the true value and you are measuring that temperature, you are getting 56 degrees and 57. Whatever the values you are getting in these two, between these two. So what is the error now? So the difference between the true value and measured value. On one side it is 0.5, on the other side it is 0.5. So if it is 57, you are getting plus 0.5. If it is 56, error is minus 0.5. So that error is plus or minus 0.5. So 56.5 is the true value. You are getting 56, that means error of minus 0.5. And you are getting 57, error of plus 0.5. So this is the error now. So percentage error means, so 0.5 is the error, by true value is 56.5. So out of this true value, how much you are getting error? 0.5. What is the percentage? Into 100. So what is accuracy now? 100 minus this error percentage. That is the percentage of accuracy. How much percent accurate your measuring instrument is? 100 minus percent error. Now in this case we take, so 0.5 is the error, maximum error we are taking. So error means maximum error. So error may be 0.2 also, but the maximum error what you are getting is 0.5 because you are getting values in between these two. So 0.5 is the maximum error, 56.5 is the true value into 100. So error is 0.9%. So if error is 0.9%, what is accuracy? 100 minus 0.9. So 99.1% accurate. So this is accurate, right? So this is accurate. It is having high accuracy. So what is accuracy? Accuracy is measured either in terms of percentage or in terms of error. How much error, that defines how much accurate also, right? If error is 1%, accuracy is 99%. So I can measure accuracy in terms of error or in terms of accuracy also. Now precision. So there are two main things here. One is the earlier one, what you have seen is accuracy. So the other one is precision. So accuracy means, once again I will tell you, it is closeness or degree of closeness of a measured value to the true value. How close your measuring instrument measures to the actual or true value of that particular physical quantity. So a physical quantity, how close you are getting, that is accuracy. If you are more closer, you are more accurate. If you are less closer, less accurate. Very simple. Now, what is precision? Is a degree of repeatability of a series of measured values. So, for example, I'll show you. If a thermometer A gives a readings as follows, for example, there is one thermometer now. This is one thermometer A, okay, which is measuring temperatures, and you are getting temperatures like this: 45.5, 45.6, okay, 45.5, 45.5, 45.6, 45.7, 45.6, 45. You are making some 1, 2, 3, 4, 5, 6, 7 measurements, series of measurements. These are values you are getting. 45.5, something like this. 45.5, 45.6, 45.7, 45.6, 45.5, 45.7, 45.5. Now these are the values we are getting with thermometer A. Similarly, you have one more thermometer, thermometer B, and you are getting values like this: 45.1, 45.9, 45.2, 45.8, 45.1, like this. Now you see here the values are, suppose the value is acceptable, that is your measuring instrument is accurate if your values are between 45 and 46, between these two values. If you look at this, all are between these two. Similarly, this one also between 45 and 46. But if you look at this, here the values are not varying drastically. 45.5, 45.6, 45.7, 45.6. Your values from measurement to measurement, they're very close. But here, even though the range is between 45 and 46, acceptable range, the measured values are changing drastically. 45.1 here, 45.9, 45.2. See, immediately there is change of 0.8 degrees, again 0.7 degrees, again 0.6, 0.7, 0.7, like this. Now, even though this is accurate, there is no precision in this. So, what do you mean by precision? The repeatability of series of measured values. The degree of repeatability of series of measured values. If you look at this, the degree of repeatability here is more, but the degree of repeatability here is less. That is, the values which are measured with the same measuring instrument, again in a series, even though you are getting within a range of 45 to 46, the values are changing drastically. So which is having more precision now. If I say the degree of repeatability is more, then in which case the repeatability is more here? In the case of A. Therefore, what I conclude is the precision of measuring instrument A is higher. The precision of thermometer A is higher. You're able to understand? So very simple. The degree of repeatability, the values that you measure with the same measuring instruments are not changing rapidly here, but here they are changing. That's why this thermometer A is having more precision. You can see here these values are closer, so therefore the precision is higher. Error terminology. So what is absolute error? So absolute means you have some measured value, you have a true value, whatever the difference you are getting, that is absolute error. Relative error. Absolute error by true value. That shows what fraction of error you are getting compared to the true value. Percentage error is relative error into 100. Errors occur during measurement due to various sources. So what are the various sources? Let us see. What are the different errors? Errors are classified into three categories. What are they? Gross errors, systematic errors, and random errors. Gross errors occur mainly due to human mistakes. That means we all do mistakes, right? Suppose you are measuring a temperature, or suppose you are doing an experiment in a lab and you are trying to measure speed of a vehicle, or you are just noting a temperature of some liquid, whatever. So you just note it. Suppose you are using a thermometer, and the thermometer actual reading is 35 instead of 25. So actual reading is 25 degrees. Here actual reading is 25 degrees, which is at room temperature, and your noting down is 35, means by its overlook, right? We see something and while noting down, we note something. So that's why it's a gross error. Error is not something which you are getting, it is not an error because of measuring device or something. It's actually gross error which is happening due to human overlook or human laziness or mistake, whatever it is. These are gross errors. And you are not using instrument itself properly. You don't know how to use it. Then also you get gross errors. Systematic errors. Systematic errors are of three types. So what are they? Instrument, because if instrument itself is having a problem, measuring instrument is itself having a problem, there is some problem with the spring, or there is some problem with a knob, whatever it is, whatever the parts they are involved in the instrument, or instrument itself is having some problem, whatever it is. So if error is because of instrument, it is an instrumental error, that is under systematic errors. Environmental errors. Suppose you are using a measuring instrument here in tropical zone, here in Asia or somewhere, and you are using the same measuring instrument somewhere in polar region, in Antarctica. So the environmental conditions here and there are different. Probably your measuring instrument itself gets affected because of the extreme temperatures it is going through. If you're using the same measuring instrument, simple measuring instrument, you take a vernier calipers for example. You're using the measuring instrument vernier calipers here in the tropical here in India, and you're using same measuring instrument somewhere in Antarctica in a polar zone, extreme temperatures where -40, -50 degrees are there. So obviously, because of the change in temperatures, the vernier calipers itself may undergo expansion and contraction. Obviously, the measured value what you get will be affected. So that is one, and observational. So the way you observe, the way you see the reading is also important. For example, you take a simple glass thermometer. We want to see the black line which is there, the mercury line. If you have to see it in a certain, you have to see exactly keeping it vertical. Suppose if you're keeping it in an angle, or you're not looking into the line perpendicularly, or you have some problem in viewing that line, obviously making so simple, you're making an observation, you're just noting down what is the temperature in this case, simple. Now your observation is slightly away from it, or your observation is slightly gone wrong. If your observation slightly goes wrong, then obviously the reading is also wrong. So this is basically systematic errors to the instruments. Basically, systematic errors are because of instruments. This is one thing that you need to keep in mind. Random errors. So random means, the word itself tells, random means we don't know what's the reason for that. That reason may be anything. So like this, randomly the errors will be. So now let us try to understand systematic errors and random errors. Suppose if this is the acceptable range, where in this we need to have, right? This is the acceptable range. This is the lower range and this is the upper range of acceptable values of any measuring instrument, for example. Now let us see. See here, your values are within this, it is acceptable, or I would say accurate if they are in these two circles. But if you look at this, all these values are in a particular place. You're getting the values. So, but only one is within these circles, so accurate value you are getting. Other things are away from this. Now, what do you mean by this is, these values very close to each other, but they are away, outside the circle. That means they are not accurate. Now, similarly, we take one more case. But the errors, look at errors, they are not random, they are at actually one place. We try to understand why this is happening. But in this case, you can see the errors are random. Here, here see how they are, the values. Even though values are close to the acceptable values, but you're getting different values in different directions. Now, what do you mean by this? All these values are concentrating at a particular place. This means here the precision is more. Here, even though they are accurate, the precision is less. So random errors means where the precision, see, you can understand this. Here the precision is more, but not accurate actually, they are outside. So why this happens? Why precision is more even though they are out of the accurate zone or whatever, even though, that means the measuring instrument, the accuracy of measuring instrument is less, or I would say the accuracy of measuring instrument is low, but still you are getting close values. Precision is high. How is this possible? Because let us see, you are using a pressure gauge, you are measuring pressure. So there is a spring problem inside the pressure gauge, which actually should change your dial gauge, right? So you have a dial gauge like this, where you have something like this, right? So it has to turn. So now what happens if there is a problem inside spring, there is a problem, and dial, whatever the dial it's supposed to move, it is not moving perfectly. What happens is, suppose if it is your pressure is 25 kg per centimeter square, and if it shows 28. So number of times you make the same pressure, instead of 25 it will show 28, which is not accurate. But because of the problem in the spring, the values what you are getting repeatedly are almost same. So that is precision. So instrument is having precision, but it's not accurate because of the problem with the measuring instrument. So this is a technical problem. So these are the errors. So what are different types of errors? We have seen gross errors, systematic errors, and random errors. So in this lecture we have seen what is accuracy, what is precision, what is error, and different types of errors. So in the next class we try to solve some problems related to this topics which we covered in first lecture and second lecture.